Hi, I'm Eric from the Thunder Pengwins, and this is the full calibration tutorial for the FTC Autonomous Builder Chat, available at ftcchat.com. The purpose of calibration is to counteract any friction or slippage that might occur in your chassis. This is often caused by excessive weight, so you should recalibrate whenever you make any big additions to your robot. Though calibration helps to make movement more precise, there's a limit to how precise you can get. When you start getting within tenths of inches, it's worthwhile to run the calibration program multiple times to check that any error is consistent. To calibrate your robot, simply follow these steps. Start on the Generate page after you've finished your Autonomous. If you're not sure how to get to this point, check out our general use guide for CHAD. First, click the down arrow to scroll down to the calibration program. Then, click Copy to Clipboard to copy all of the code. Create a class under Team Code Java org.firstinspires.ftc.teamcode and call it Calibrate. This is case sensitive, so make sure to capitalize the C. Use Ctrl or Command A to select all of the code and right-click Paste to replace it with all of the calibration code. There should be no errors. Configure your robot in the driver station or robot controller app. Make sure the motors match the gear ratio you entered, and you name them according to the hardware map in the code. For two-wheeled chassis, these would be left and right, while for four-wheeled chassis, it's front left, front right, back left, and back right. Plug in your robot controller phone and upload the code by pressing the green triangle. When it's finished, plug the phone into the robot, activate the configuration you made earlier, and place the robot on FTC regulation foam tiles. Get a tape measure and lay it out in front of your robot, starting at the axle of the wheels. Run the calibration program on your driver station app. Its goal is to move exactly 20 inches. Measure the distance. If it's within an inch of the goal, you may want to run it again or check for consistent error. If there is no consistent error or it meets your standards of precision, you are done calibrating. Otherwise, if it's more than an inch off or the error is consistent, find a new bias using the formula 20 divided by distance traveled. In the code where bias is defined, change the number to whatever you've calculated. This should be a decimal from around 0 to 2. If your new bias is much larger than this, there may be a problem with your encoder or gear ratio calculation. With the bias changed, run the program again. It should be corrected right away, but if it isn't, keep updating the bias until you know something is wrong, or it moves exactly 20 inches. Once you found a bias that works, make sure to find and change the bias for all CHAD programs that run on the robot you calibrated to. In the future, if you're making a new program for the same robot, you can specify the bias in the website and it will generate the code with the robot already calibrated. If something goes wrong, there are 3 go-to things to check: inputs, wires, and the battery. If your bias is extremely large or small, it is likely that some inputs are incorrect. Remember to check diameter and encoder CPR in addition to gear ratio. If the program is behaving inconsistently, check that all the wires are connected properly, especially those connected to encoders. If the robot isn't moving at all, check that the battery is charged and the phones are properly connected. For more information, visit the Tips and Info page at ftcchat.com. A video on adjusting generated code is coming shortly. Stay tuned for more.